Taking a full backup is important, but it's not the only option available to us. Let's learn more today. Welcome to this video on backing up SQL Server. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video, I provided a bit of motivation for why backups are important. I also demonstrated one way to take a full backup in SQL Server. Along the way, I skipped over several things to simplify that process. In this video, we are taking a second walk through the park on backups, but this time we are going a bit deeper and sampling the various options available to us. Let's dig in. There are three major topics we will hit in this video: recovery models, types of backups within SQL Server, and backup technologies outside of SQL Server. Let's start with a discussion of recovery models. The whole point of a recovery model in SQL Server is to manage how we maintain the transaction log for our database. To oversimplify things here, the transaction log is our bookkeeping method for how data changes in the database. When we run a statement to modify data, what we're doing is, first, writing the prospective changes to the transaction log. Then, SQL Server makes those changes to data files. The reason we do it this way is to guarantee that our data will remain in a transactionally consistent state. If my server reboots or my client crashes in the middle of a transaction, SQL Server can mark the incomplete transaction and roll it back. We don't have a situation in which some of the data received an update, but the rest did not. This transaction log also allows us to control how much history we maintain outside of the database. If I have a full database backup at 2 p.m., and I also have the transaction log for everything that happened after 2 p.m., I could recreate the database as of any point in time after 2 p.m. by restoring the full database backup and then replaying transactions until I get to the desired stopping point. That leads us to the idea of point-in-time recovery, and this takes us to recovery models. There are three recovery models available in SQL Server: simple, full, and bulk logged. The easiest recovery model is simple. In this mode, we take full backups, just as we did in the prior video, but we never back up the transaction log. Instead, SQL Server automatically marks transactions after they've completed, indicating that we can overwrite that part of the file. The plus side to the simple recovery model is that we rarely need to think about transaction log management. As long as we don't have too many giant, long-running transactions, we typically reach a steady state of how big that transaction log file is, and we don't have to think about it anymore. But this simplicity comes with a major downside. We don't have that history of transactions that I talked about. Therefore, we cannot perform point-in-time recovery and instead can only recover to the point where we have a full backup. The opposite end of that spectrum is the full recovery model. With the full recovery model, we need to take not only full backups of the database, but also transaction log backups. Basically, we're keeping the history of those transactions until we've backed them up to disk in a transaction log backup. The benefit to this approach is that I can take that 2 p.m. full backup, and as long as I have all of the relevant transaction log backup files, restore us to exactly how the database looked at 2:36 p.m. and 28 seconds. But the drawback to this is that we now need to take those transaction log backups, and if we don't take a backup, the transaction log will continue to grow until it runs you out of space on the disk. This is a surprisingly common occurrence in organizations that don't have their automated database backup solution set up correctly, or at all. In between these two, there is a third recovery model, bulk logged. Bulk logged isn't really the middle point between simple and full. It's more like the full recovery model with a minor exception. And that minor exception has to do with bulk copy operations. With minimal logging, we only log the information necessary to recover a transaction, but we do not support point-in-time recovery on these bulk logged operations. This means that write operations to the transaction log may be simpler in some circumstances, and bulk inserts can be considerably faster than if we are performing full logging. But it also means that if I have the recovery model set to bulk logged, I can only restore to the specific times in which I've taken transaction log backups following a full backup. I can't back up to 2:36 p.m. and 28 seconds if my transaction log backups were at 2:30 p.m. and 2:45 p.m. Instead, I could only restore to 2:30 p.m. or 2:45 p.m. in that case. I will show you in the demo how we can switch recovery models per database and also some of the consequences of a switch. In the meantime, let's talk about the types of backups that you can take. We have quite a few types of backups available to us, and which ones we should use will depend on the situation. The first backup type is the full backup, which is what we saw in the prior video. A full backup is a backup of the entire database, including all data files and the part of the transaction log file that we need to ensure that we can recover the database after we restore a full backup. Each full backup contains all of the data in the database as of the moment the backup completed, ignoring transactions in process. In other words, if it takes 2 hours to complete a full backup and I kicked it off at noon, finishing at exactly 2 p.m., the data will be everything in the database that we successfully committed prior to 2 p.m. The second type of backup I want to talk about is a transaction log backup. I've already mentioned this once before as well. This is only something that you would take for databases in either the full or bulk logged recovery model, and its purpose is to make a record of all of the committed transactions since the last full backup or transaction log backup. As a quick note, we need to have a full backup before we take a transaction log backup, as the idea is that transaction log backups are keyed to a full backup. They describe transaction log changes that have happened since that full backup. Also, you can think of transaction log backups as a chain. Not only do we need that base of a full backup, but we also need all of the transaction log backups from that full backup to the latest one in order to restore to the current point in time. If I have a full backup that finished at 2 p.m. and I take transaction log backups every 10 minutes, I'm going to need that full backup as well as 6 transaction log backups if we want to restore the database to its state as of 3 p.m. If we lose the transaction log backup file for 2:40 p.m., we can't restore our database past the last known good transaction log backup that we have, so we would not be able to go past 2:30. The third most common type of backup is called a differential backup. To understand why these backups may be useful, we have to think about how long it takes for a full backup to complete. If you can take a full backup of your database in 10 minutes, well, you probably don't need differential backups. Instead, differential backups exist for scenarios in which it may take hours to complete a full backup. What a differential backup does is it takes all of the changes that have occurred since the last full backup and saves those. Now you might think, well, hey, that's what a transaction log backup is doing, right? Not quite. You see, a transaction log backup keeps track of what has changed since the last full, differential, or transaction log backup. A differential backup takes everything since the prior full backup. What this means in practice is that a differential backup can act as a checkpoint of sorts. Let's say that we run a full backup once a week, Sunday at midnight. Then we run differential backups the other 6 days of the week at 4 a.m. We also have transaction log backups happening every 10 minutes of every day. If I discover a problem and need to roll back to how the database looked on Friday night at 8 p.m., or let's say our server crashes and we need to restore everything up to Friday night at 8 p.m. on a new server, well, it's going to look one of 2 ways. If we do not use differential backups, we will need the full backup from Sunday and every transaction log backup since the full backup. Assuming 6 transaction log backups per hour, well, that's going to be about 144 transaction log backups per day. And depending on when our full backup finished, we might need more than 700 transaction log backups to complete restoration. That is fine from the standpoint that SQL Server can definitely support this, but there is a small logistical challenge in making sure that all of these transaction log backups are there and that they're valid. Meanwhile, if we do use differential backups, we might take one differential backup a night. Our Friday night differential backup didn't run, but we do have one for Thursday. So what I need in that case is my full backup, the differential backup for Thursday and each transaction log backup since that Thursday differential backup completed. At this point, I might only need about 95 or so transaction log backups to complete the process. Differential backups are typically smaller than full backups, but not always. The size of the differential backup depends on how much activity has occurred on that SQL Server instance since the last full backup. If there's only been a little bit of write activity, the differential backup will be small. But if we have a very heavy write load, a differential backup may end up being larger and slower than a full backup. Now, if you regularly see that scenario, it's a good indication that you will want to increase the frequency of full backups, replacing some of those differentials. Going back to our example of full backups on Sunday and differentials throughout the week, suppose that Friday and Saturday differentials are at least as big as the full backup, and maybe sometimes even larger. In that case, we may instead want to take full backups on Sunday and Wednesday, and then differentials the rest of the week. Those are the three most common types of backup you will find in SQL Server, but there are a few others that you may hear about, so let's talk about them. First up is a copy-only backup. A copy-only backup is actually a full database backup, but it has one special property. It does not reset the log chain. In other words, let's go back to our scenario with a weekly full backup, nightly differentials, and transaction log backups every 10 minutes. All of the differentials are keyed off of the weekly full backup, and transaction log backups build on either the full or differential, depending on whichever came last. But what if I need to take a backup of the database and restore it to QA? If I take another full backup, the log chain resets, and now I need to keep track of this one-off backup. A non-DBA who is not really aware of how log chains work might take that backup and then delete the full backup file, thinking that, well, everything's just going to continue to work fine. But now your differential and transaction log backups will be useless until your next full backup, and that's an awful situation. Instead, we can take a copy-only backup, which does not reset the log chain. Our prior full backup is still the one in charge, and this is just a one-off backup that we could safely delete after we are done with it. It's absolutely fine to take copy-only backups outside the normal schedule of full backups, and that can be really useful for tasks like setting up availability groups where you need a recent full backup as a starting point. Speaking of log chains, you'll hear about something called a tail log backup. This is basically a final transaction log backup that captures everything since the prior transaction log backup and would run right before another operation. There are a few circumstances in which you might need a tail log backup. The most common one is if you're trying to restore to a point in time between your last transaction log backup and the current time. For example, if your last transaction log backup was 8:06 p.m. and you want to restore to how the database looked at 8:08 p.m., well, you'll need the tail of the transaction log to do that, and so you would need to create a tail log backup. Similarly, if you have a database that is currently offline and failing to start, you would need to take a tail log backup before restoring that database. The last type of SQL Server backup I'm going to talk about here is file group backups. This is more of an advanced scenario, but the general idea is that you can back up those separate MDF and NDF, that is, Mike Delta Foxtrot and November Delta Foxtrot, those data files in SQL Server independently. This is particularly useful if you have certain file groups that are read-only, meaning that the data simply won't change. In that case, why take a full backup that includes those read-only file groups every single time? The data won't change, so if you simply had an older copy of the file group which was exactly the same, well, that should suffice for a restoration job while reducing the amount of time that it takes to back up the relevant read-write parts of the database. Also, you can restore file groups separately from one another. So you might have a primary file group that contains database metadata and certain critical tables, maybe a different file group with table data, a third file group with some non-clustered indexes, and even a fourth file group with read-only archival data. If you manage those file groups appropriately, you could restore the primary file group to make the database come online. Then you could restore each of the file groups in turn to recover that functionality while also letting people get back to some level of work as soon as possible. Finally, I would be remiss if I did not talk about backups outside of SQL Server. For a long time, SQL Server has had something called the Volume Shadow Copy Service, or VSS. This allows applications to take snapshots of SQL Server files as of a particular point in time. Products like VMware and Hyper-V support this, as well as certain SAN tools. The main downside to taking these snapshots outside of SQL Server is that you are relying on your hypervisor or storage admin to manage snapshots, and you might lose some of the nuance of point-in-time restoration or having different backup strategies for different databases. Also, the VSS service would freeze I/O operations while it took a backup, meaning that backups could block user activity for up to, say, 30 seconds in some of the worst cases that I've seen. Typically, that freeze is a good bit shorter, and it's often sub-second if you have fast enough disk, but if things go wrong, your users will feel it. As of SQL Server 2022, there is something called a Transact SQL Backup Snapshot. In this scenario, we are still having an external service take the backup, but we are not using the SQL Writer or the VSS service. Instead, there's a different mechanism to suspend I/O that should be considerably faster. Okay, we've spent a lot of time talking about recovery models and backup types. Let's go into the demo and try out a few of these. In this demo, we are going to take a look at recovery models and backup types in that order. I have here a SQL Server instance with a variety of recovery models. If I right-click on, say, Chicago parking tickets, I can select Properties and then navigate to the Options page. This tells me that my database is in Simple Recovery Model. If I want to change the recovery model, I can select the drop-down list and choose a different one, then select the OK button. I'll switch it over to Full and then save my change. By the way, this technique of discerning recovery model works fine if you have a few databases, but it is not at all efficient. Instead, let's open a new query window. In here, I'm going to select Name and Recovery Model from sys.databases. This gives me the recovery model for each database. I can also set the recovery model in T-SQL. Let's do that for the Chicago parking tickets database, setting the recovery model back to simple because, well, I changed my mind. We need to know which recovery model we are in for a database, as that will affect our need to take transaction log backups or our capability for point-in-time recovery. For example, the Analyzing Biz Data database is using the full recovery model, so I can perform point-in-time restoration. But Chicago parking tickets is using the simple recovery model, so I can only restore to the last full backup. Now, let's take Analyzing Biz Data as an example. I'll right-click on it and go to Tasks, and then choose Backup. I have a full backup already, but I haven't taken a transaction log backup in a while. In fairness, I don't actually modify data in this database, and it is a development instance running on my local machine. Nonetheless, the modal dialog will default to a full backup. In the backup type dropdown, I'll choose transaction log. This is going to give me a backup of all log activity since my last full backup, but I don't want it going in the same .back file as my full backup. You can technically do this, but I like having the files be separate. That allows me to move full backups off to write once, read many storage if I want that added level of security. But a simpler reason that I like having these be separate files is it reduces the risk of me accidentally overwriting my full backup because I messed a setting up in the backup operation. So let's remove the file already in there and add a new one. I'll name it Analyzing Biz Data, and then the year, the month, the day, the hour, and the minute. .trn. By including the date, hour, and minute in the backup file, it makes it easier for me to sort those files and ensure that I have a continuous chain going back to my full backup. Switching over to media options, I have two media set options. I can back up to the existing media set or back up to a new media set. I'll admit that I pretty much never care about media sets. I know it was much more important in the days of backup tapes, and I'm not going to poo-poo DBAs who do care about media sets and actually do take advantage of that metadata. I'm just not one of those people, so I'll leave it alone. Next, we have a few options for reliability. We can verify the backup after it finishes. If the system I'm on is not too busy, I do like ticking that box. Second is performing a checksum before writing to the media. That way, if there is on-disk corruption that the backup process can quickly find, it can alert you before writing out a backup and tell you up front that you have a problem, rather than quietly writing corrupted data to a backup. Corruption is its own set of topics, so I'm not going to dig in further here, but I do highly recommend running dbcc checkdb as part of an automated job to check for corruption. Our third option is an interesting one. Truncate the transaction log or back up the tail of the log and leave the database in a restoring state. We normally want to truncate the transaction log as we're simply keeping track of the work our database has performed and telling it to, hey, keep up the good work. But if I want to perform a point-in-time recovery of the database, I will want to select the second option when I take that final tail of the log backup. Then I'll be able to restore the database to whatever point I desire, so long as I have the appropriate full, differential, and transaction log backups. Now we'll go back to backup options. We have the backup set, which is another piece of metadata I tend not to use very much. Again, this was quite useful in the days of tape drive backup, but I'd argue it's much less so today. We do have backup compression and encryption options as well. I'll leave these at those defaults and select OK to take this backup. This backup didn't take very long because, as I said, I don't really write into this demo database. Nonetheless, I can select OK to finish the backup. Now let's see what options are available to us in the Chicago parking tickets database. I'll right-click the database and then select Tasks, and then Back Up. In the Backup Type menu, we can see full and differential backups, but no transaction log backups. That's because we are in the simple recovery model. Now, one thing that we get with full backups but won't appear for other types is this copy-only backup checkbox. As I mentioned in the classroom, ticking this means we don't reset the log chain. So this would serve as a one-off backup that I don't need to manage like I would my normal backups. I have zero problem with devs, DBAs, or other authorized parties taking copy-only backups at, well, pretty much any time. The trick is, make sure that these are copy only, as otherwise you reset the log chain, and now you need to maintain this full backup as the starting point for the new log chain, at least until your normally scheduled full backup runs. If I navigate to the Media Options tab, we can see that we cannot select either of the transaction log radio buttons, and that makes sense as these are only for transaction log backups. The rest of the options are the same. Switching over to backup options, we've covered those between the prior video and our transaction log backup demo, so that's going to do it. We'll save file group backups for a future video. And that's our demo. Now, normally my outros tend to be short and sweet. This one will be a little bit longer because I want to talk about the ideas of RPO and RTO and how those affect what we've learned. So we're going to head back to the classroom. Recovery point objective and recovery time objective are two critical parts of business continuity. The idea of RPO is how much data can we afford to lose in an outage? If we can afford to lose today's information and just have employees rekey that data from today, we have an RPO of 1 day. If we cannot lose more than 15 minutes of data, our RPO is 15 minutes. If we cannot lose more than a second's worth of data, our RPO is kind of tough to meet and the company is potentially going to pay a whole lot of money for this level of service. Recovery time objective, meanwhile, asks the question, how much time can we take during an outage before we have to be back up and running? The RTO is also in the form of time, and it might be something like 12 hours, 24 hours, 48 hours, 5 minutes. RPO and RTO are both business decisions, not technical decisions. The technical decisions we make are to support RPO and RTO. And as a general rule of thumb, the smaller your RPO and RTO are, the more money the company will need to spend to achieve these. A 12-hour RPO and a 12-hour RTO is pretty easy to achieve for most databases. A 12-second RTO and RPO is nearly impossible and requires spending a lot of money to support essentially making multiple copies of the data and synchronizing them across replicas in near real time. But if you just start asking people, hey, what is the RTO and RPO for this product? A lot of them won't know the answer to that. And so they'll start with, well, none. We can't lose any data. We can't have any outage. However, no lost data and no outage is fantasyland thinking. Every system, no matter how robust, has the possibility of an outage, and businesses need to be able to plan for those scenarios. So the second round of asking, no, but really, what is your RTO and RPO? Well, this will often result in a negotiation of sorts. The business people who have thought about this may need to go back to customer contracts and see if the company has provided certain levels of service to customers. If so, we're going to have to support those contracts. If you don't have explicit SLAs or your business person doesn't know the answer, you might need to hunt around for someone who can make a decision. One thing I like showing people is a simple but very effective chart from Brent Ozar covering RPO and RTO requirements and showing order of magnitude costing given certain objectives. I'll leave a link to where you can get this in the show notes. But for some really quick advice regarding RPO, when it comes to backups, here are a few tips. First, most production databases should be in the full recovery model. Bulk logged has specific uses, but I would argue you need a good reason to use it over full. The simple recovery model is fine for databases you don't really care about, but realize that your RPO will be no better than your full backup frequency. Speaking of which, take regular full backups, daily for all the databases you can get away with, and weekly or so for the really large ones. If you are taking daily full backups, you won't need differential backups. Save those for the really large databases. When it comes to log backups, take your RPO and cut it in half, and that's the minimum log backup frequency you should use if your recovery strategy is to restore from backup. For example, if your RPO is 1 hour, make sure you're taking a log backup at least every 30 minutes. That way, if your last log backup failed and your server crashed right around the same time, you can still stay within the 1 hour window. But that's also the minimum log frequency. I also like to put a rough cap on log growth. If you have databases with frequent changes to large percentages of data, you'll want to take transaction log backups even more frequently so that you can make those log segments available sooner and reduce the risk of your log file growing. If you tell me that you're taking transaction logs every 5 minutes or even every minute, I won't blink. I think that's a smart thing to do. For classical data warehouses in particular, I do sometimes leave these in the simple recovery model, with the idea being that you should be able to rebuild a data warehouse from scratch if you need to. And these tend to have nightly reload jobs, so you're not constantly changing that data throughout the day. But just be aware that if your RTO is fairly low for a warehouse, you may still need to be in the full or bulk logged recovery model so that you can use recovery techniques like log shipping or availability groups. Also, if you have a data warehouse in which you're getting frequent intraday updates, just treat it like a regular relational system and use those full, maybe differential, and definitely log backups. In the next video, I am going to get us out of the GUI and write a bit of T-SQL to back up those databases. We'll have links and show notes in the description below. And until we see each other in the next video, take care.